Good afternoon everyone, I am Mr. Ish. Counting atoms is the name of this particular video. We have to find the number of atoms in each of these three specific instances. Question number 1, 3 moles of copper. How many atoms of copper are there in 3 moles of it? 7.2 liters of helium gas at STP. And lastly, how many atoms of HCl gas would be generated by a reaction of 3 grams chlorine and 5 grams hydrogen? How do you go about doing this? Remember this conversion factor. 1 mole of anything is always equal to your Avogadro's number, which is 6.022 times 10 to the 23 atoms. 1 mole of anything is equal to 6.022 times 10 to the 23 of that thing. 1 mole of atoms is equal to 6.022 times 10 to the 23 atoms. Bringing that into play, it's not too hard. Looking at question A, you have 3 moles of copper. All you're going to do is 3 moles of Cu multiplied by 6.022 times 10 to the 23 atoms, and we're doing everything here in the proper factor label method per mole of copper. And you'll see this will cancel out with that, and all you have to do is just do 3 times 6.02 times 10 to the 23 and they'll give you your answer. We have an answer coming out over here to be 1.81 times 10 to the 24 atoms, and that would be the answer of the first question, and not too hard, right? If you think about it, it wasn't too hard. 1.81 times 10 to the 24. That's the answer for question A. So you have to individually in each instance always determine the moles of that specific item, then you use that factor, each mole having 6.02 times 10 to the 23 atoms of that particular item, and then you go from there. How about question B? 7.2 liters of helium gas at STP. Remember, you always have, with regards to this, a volume occupied of 22.4 liters of any ideal gas, 1 mole of that particular gas having that particular volume. And how would you determine the number of atoms from that? How about this? 7.2 liters of helium at STP. It'll always have 1 mole of that, will always have a volume of 22.4 liters at STP. And then you'll have the Avogadro's number coming in, 6.022 times 10 to the 23 atoms per mole of helium. Now see how things will cancel out. Liters of helium with this liters here, moles of helium with that. You'll have 7.2 divided by 22.4 times 6.02 to exponent 23, and that'll give you your answer. The answer that I'm getting over here is 1.936 times 10 to the 23 atoms, which I'm going to put right here, 1.9, and I'm going to round it up, 1.94 times 10 to the 23 atoms. Again, you have to remember here that a volume occupied by 1 mole of a gas at STP, ideal gas, is 22.4 liters. That's one conversion factor, and then this here per mole is always that, 6.02 exponent 23. So there are 2 conversion factors which are coming into play over here to convert this liter into the number of atoms. This last question is not too hard, but you'll have to do a little bit of work. You have chlorine and hydrogen gas coming to form HCl. H2 plus Cl2 to form HCl. We're not worrying about the direction of the reaction and the equilibrium and all of that, but you have to balance it, and this is exactly what you have. For chlorine and for hydrogen, you have a mass given. You have to see which one is basically the limiting reagent or limiting reactant, and just visually you know this right here is, because when you divide 3 by the molar mass of this, it'll be a much smaller number than 5 divided by the molar mass of that. So you can even omit hydrogen if you want. You don't even have to waste time. You can know right off the hand that this right here is your limiting reagent, because the molar mass of this is very high. For this it's not that high. So you'll have 3 grams chlorine times, what's the molecular weight of chlorine? It's 35.5 times 2, 1 mole Cl2 per 71 grams, that's the molecular weight, times HCl. You have 2 moles HCl generated for each mole of chlorine. See, 1 mole of chlorine, 1 mole of chlorine gas, times 6.022 times 10 to the 23 atoms per mole HCl. The grams chlorine, and I could have put a chlorine here, will cancel out with this, the mole Cl2 with that, mole HCl with that. Now look at all the numbers which are here. 3 times 1 times 2 times the Avogadro's number divided by 71, and that'll give you your answer. So 3 times 2 times 6.022 exponent 23 divided by 71, I'm getting a value here of 5.09 times 10 to the 22 atoms, and that would be my answer. 5.09 times 10 to the 22 atoms, and the answer should be right. And that right there brings us to the end of this video. All your 3 answers are here and they should be good. Thank you for joining me. Have a good day.